So good morning to one and all. So my next session will be on tolerances. So the aim of the session is to familiarize the students with the concepts of tolerances, and the instructional objectives are: the session is designed to understand the concepts of tolerances and to understand about different types of existing tolerances. The learning outcomes are at the end of the session. The students can able to define different types of tolerances, and they can able to find the clearances and tolerances for various existing problems. So first I'll start with the definition of a tolerance. Already I just give a small glimpse about the tolerance in the previous session. The term tolerance refers to the difference between the maximum limit and the minimum limit of a dimension of a given part. In other words, the tolerance is the maximum permissible variation in a dimension. The tolerance may be of two different types. One is unilateral, other one is bilateral. Okay, this tolerance is nothing but it refers to the difference between the maximum limit and the minimum limit of a dimension. There are two different types of tolerances are there: uni, bi. I'll explain the difference between those two. Whenever a tolerance is allowed on one side of a nominal size, you see this is a nominal size of 30 diameter is there. Okay, it is called unilateral because the tolerance is allowed on only one side of the nominal size. One side, in one side it is minus 0.03, in other side it is 0, which means here the tolerance is allowed only on one side for the nominal size 30. This will be called as unilateral system of the tolerance. Okay, so either here, for example, you see 30 minus 0.03, this is also called unilateral system only. Okay, which means for the existing nominal size, either in one side only the tolerance is allowed. Such type of tolerances are called unilateral tolerances. Next, bilateral. The tolerance is allowed on both sides of nominal size. You can see the example here. The nominal size is 30, for which in the upper we have plus 0.03, here in the lower minus 0.03. These two are the tolerances which are allowed for this particular nominal size of 30 diameter. This will be called as bilateral system of tolerance. Okay, next let me do one problem on this to understand more. The following limits are specified in a limit system to give a clearance fit between a hole and shaft. For hole, okay, you see 20 plus 0.03 minus 0.00 mm. Okay, so these are the tolerances given for a hole, okay, on either sides, and for shaft it's a minus 0.006 and minus 0.0202, and we can able to determine about the basic size and the tolerances on shaft hole only. Here you see, first I am determining the basic size. The basic size is the same for both shaft and hole. What is the basic size here? Here itself you can see 25 mm is the basic size, which is same for both shaft and hole. Coming to the tolerances on shaft and hole, okay, the tolerance on hole, you see hole, so this is hole now. For this you see the tolerance on hole will be 25 plus 0.003 minus 25 minus 0.000. The total will be 0.03 mm. This is called the tolerance on the hole, 0.03 mm. Coming to the tolerance on shaft, You see the shaft, tolerance on shaft will be 25 minus 0.006 minus of 25 minus 0.020. So this is the permissible tolerance on the shaft. Like this, we can able to determine the tolerances for shaft and hole for the given limits. And also the tolerances for a hole and shaft assembly have a nominal size of 50 are as follows. For this, try to determine maximum and minimum clearances and also the tolerances on shaft and hole. You know how to determine tolerances on shaft and hole? Now the new one is maximum and minimum clearances for the given hole and shaft assembly. Determination of clearances, first I am explaining. The maximum clearance will be, okay, you see on the hole the maximum clearance will be 50 plus 0.02, which is 50.02 minus 50 minus 0.02 of the shaft. This will give you the maximum clearance, that is 0.10 mm. Minimum clearance will be, okay, from the hole it 50 plus 0.00, it's 50 minus 50 minus 0.005. So 0.05 mm is the minimum clearance. Okay, so based on this, the given dimensions of the hole and shaft permissible limits only, we can able to identify the maximum and minimum clearances. The maximum clearance in the but it is the difference between the maximum values of hole and shafts. That's why the difference of 50.02 and 50 minus 0.02 only, and the minimum clearance 50 minus 0.005. And coming to the tolerances, as you know, for the hole it will be, okay, 50 plus 0.02 minus 50. The whole tolerance will be 0.02 mm only. And coming to the shaft tolerance, it is 50 minus 0.05 minus 50 minus 0.08, which is around 0.03 mm. This is the shaft tolerance. Like that, from the hole and shaft assembly with some nominal size or the nominal diameter, we can able to estimate the maximum and minimum clearances and the tolerances on shaft and hole easily. Okay, hope you understood about the tolerances and how to calculate the tolerances for a shaft and hole assembly. Okay, and the activities related to the session, the students could be given engineering drawings and they asked to calculate and apply the tolerances for different components. It's a kind of a practice session for them to learn about the tolerances for different existing components. And coming to the examples, include some real world examples and extracts from various articles or industrial practices that illustrate the application and significance of tolerances. These also may include some case studies of the companies that have excelled in tolerance management. Take any particular company, you take any parts manufacturing company, okay, a spare part manufacturing company, you take a bolt and nut assembly and just try to get some information from that. You try to understand the application and significance of the tolerances in between an assembly for every parts from the manufacturing industries or any industry practices. In this session so far, you learned about the importance of tolerances, different types of tolerances, unilateral, bilateral, and how to find the clearances and tolerances also we discussed so far. And these are the self-assessment questions. Which type of tolerance allows for equal variation in measurement values above and below the nominal value? The answer is above and below the nominal, bilateral tolerance. And what is the term for the difference between the actual measured and nominal value of a part of a component? It's a tolerance error. These are some of the terminal questions. These are the textbooks and reference books related to this session. Thank you very much.